one more step. Ask them to log in to my portal.
Okay, good morning, everyone. How did your homework go? Do you have any question about it? I know some of you did it and some of you did not do it on my lab yet. So number 18. Okay, let's look at that. Oh, all right. I'm going to try to put the book in front of us, see if this helps. I will try. If I can't, I... All right, so do you guys see it? Very good. So number 18, I will pick the one in the book. I know that on my lab you have a variation of it, but it shouldn't matter. All right, so we go through them one by one. Let's see G of 2. So this is 2. What is G of 2? I would like answers 2. Do you agree this is 2? So G of, no, Austin. G of 2 is not 2. Right, it's 3. Because if this is 2, G of 2 is where it's the full circle. Not, yeah. So solid dot, exactly. So G of 2 is equal to 3. Good. Now, what's the limit as x become close to 2 from the left of G of x? So this is my 2. And when x become close to 2 from the left, so these are what I'm looking for. Strictly less than 2, tiny bit less than 2. What happened? The output value of G are becoming close to, now you guys can let me know. 2, do you agree with Chris? Yeah, absolutely 2. Okay, now keep going. When x become close to 2 from the positive, it means x is a little bit bigger than 2. So you're thinking 2.1, 2.01, 2.001. So I'm right here. There, these are the output I'm looking for. So these are the input I'm looking for. So the output are becoming absolutely close to 3. Okay. Now, what's the limit as x become close to 2 of G of x now? What's the limit? Does not exist. Exactly. So when the limit from the left is different from the limit from the right, the limit does not exist. So this limit does not exist. Okay? So let me write on a piece of paper so you guys know exactly how we handle that. So since the limit from the left of the function is different than the limit from the right, so the limit to exist, from both sides, they have to approach the same thing. Okay, so from both sides, they have to approach the same value for the limit to exist. If this doesn't occur, it means that the limit as x become close to 2 of G of x doesn't exist. Does not exist. Okay. All right. Now let us proceed. What is G of 3? Okay, I look at my graph. This is 3. What's the output? So I look for the solid dot. So G of 3, the solid dot is at 2. I agree. The solid dot is at 2. Now, what's the limit as x become close to 3 from the left? It means we are a little bit less than 3, 2.9, 2.99. That's what I'm thinking of. All right, what's gonna be answers? Absolutely, the answer is 3. Now what's happening from the right? Again, these are the output I'm looking for. These are the output I'm looking for. This is exactly what I'm looking for. What are we getting close to? 2. 2 would do it. Now what's G of 4? This is my 4. That's the output at 4. How much you guys giving me? 3, because this is 4. The output, I go all the way till I hit the curve. This is nothing more than 3. And what's the limit when x become close to 4? Okay. All right, 3, because whether you go from the left or you approach 4 from the right, it doesn't really matter. The output is really becoming close to 3. So this also is equal to 3. Okay. Anything else before we proceed? All right. Right, so today we are going to start computing those limits, but we're going to do them algebraically. So we did them a lot graphically, and we did them like numerically by plugging in values, because sometimes even algebraically we don't know what to do with them. So today we're going to take some limit, not hard one, but we have to do them algebraically. So section 2.3, the book calls it Technique for Computing Limits. So 2.3. Okay, so techniques for computing limit. Basically, it's how to compute some limit algebraically. That's really what is it about. Techniques for computing limits. Okay, so I start with very simple limit, very, very basic limit, and then we go from there. So let me start with simple limit. Okay, so let me ask you the following. So suppose I take the limit as x become, let us say, close to 4 of x. What will be your answer? It means when x become close to 4, x itself, take what value? So my function here is x. So when x become close to 4, what type of value x takes? So it takes 4, because if you take value close to 4, 4.1, 4.01, x is becoming close to 4. So in general, if you have x itself, as x become close to a number a, the limit is you just plug in a. I mean, that's really as simple as that. Now, suppose I take the limit as x become close to 4 of x squared. Okay, so my function here is actually x squared. This is my function, x squared. Okay, and I compute the limit in this case. So I take values close to 4 and I see what happened. What do you think the answer is, and is it hard? So basically 3.99 squared. 3.999, you square it. 4.001, you square it. What do you think the answer is going to be in here? It's basically you plug in 4 for x, which is equal to 16. So in general, if you're computing x to any power, when x becomes close to a, it's nothing more than you plug in a for x. Now those are very simple limits. Intuitively, they really make sense to us. And even if you're taking the nth root, so it doesn't really matter, you basically plug in the a for x, okay? Now there are other also simple limits. So let me, instead of stating theorem, let me just do them intuitively. Suppose I tell you, find the limit. of the following expression. As x become close to 2 of x squared, let's multiply it by 4, plus 2x, for example, plus 1. Okay, so when I take x very close to 2, this expression will become basically close to 1. Let's do it step by step. When x become close to 2, this will become 2 close to 4 times. So when I plug in value close to 2 here, 2.01, 2.001, 1.99, this is really going to get values close to 2 square. So we're just really plugging in. Here also, when I take values close to 2, like 2.01, 2.01, it's 2 multiplied by 2.01. So this will be close to 2 times 2. So really we're plugging in the 2 in this scenario. 1 is 1. I mean, there is nothing really happening. So this limit is going to be nothing more than 4 times 2 squared plus 2 times 2. So when we have simple functions that we call polynomial like this, we just add them. And now if I add them, I will have 16 from here, plus 4, which give me 20, plus 1, which gonna give me 21. Okay, so still we are in a simple scenario. Now another idea. Suppose I take the limit as x become close to 2 also, but now I'm going to take 4x squared plus 2x plus 1, so the same thing as before. Let us me divide it by x plus 3, for example. Okay, so what's going to be the limit? It means when I start taking those values of x close to 2, then this quotient, basically, this ratio of 2 functions is going to become close to what? Okay, let's see. So if I take values close to 2, this numerator is going to become close. So this term will become, this term like before, is going to come close to 21. So if I plug in values close to 2, the numerator will become close to 21. Now what's happening down here? When x become close to 2, intuitively, this will become close to 5. So when I start computing this ratio, I will usually get, I should get 21 over 5. Okay, so again, I am actually plugging in. So the rule in general is the following. If I have dividing two functions by each other, so if I need to find the limit as x become close to a number a of one function divided by another, two functions, okay? So here, my function is 4x squared plus 2x plus 1, and the other one is x plus 3. So basically, I can split. So I can compute the limit of the numerator, what happened to the top, divided by the denominator. I can do that. I can split. But here's the thing. Whenever I have denominator, we have issues. So this is work as long as this quantity is different from 0. But that's where really I have issue. That's what we're starting having issue. So this property work as long as my denominator is different from 0. So the problem is, which is what our starting issue was, how to deal with a problem where when I need to find the limit, my denominator is becoming close to 0. So that's really the issue. If the denominator doesn't go to 0, there is nothing. We just plug the value that we're getting close to. If the denominator goes to 0, and then that's a different ball game, and that's what we're going to actually start thinking about. So let's talk about this issue. Let's talk about this issue. So to emphasize what I'm talking about, suppose I tell you find the limit, just make sure that the limit, let us say, as x become close to 0, again, a simple scenario of x plus something like that. So here, when x become close to 0, numerator close to 6, it's the denominator that worries me. When x become close to 0, here my denominator become close to 1. So in this scenario, I have nothing to worry about. It's 6 over 1, which is equal to 6. So now what happens when denominator is 0? So let's write it down. That's what I'm working for. So the problem is what happened? What happened to this limit of f of x over g of x if I have a ratio? Basically, my concern is the denominator equal to 0. That's really what my bigger problem is. Okay, there are two scenarios. One scenario that we're going to take up next section, and one scenario we're going to take up the following section. But I have to tell you what the scenarios are and which one we take next time, which one we'll take this time. Okay, the scenario one is the following. Let us say we have the numerator, the limit of the numerator is not 0. Then let's see what happens. So I always elaborate with examples. So suppose I tell you find the limit as, let us say, x goes to 1 of x over, or x plus 2, let us say, over x minus 1 square. Okay, so let's analyze this. When x becomes close to 1, the numerator becomes close to 3, the denominator becomes close to 0. What's going to happen in this scenario? Let's think a little bit about it. I'm going to take a small table, and then I'm going to figure it out. So here I'm taking the values of x, and here I take x plus 2 over x minus 1 square. And I'm going to start thinking, what happened here when x takes value close to 1? Okay, let's pick values. Suppose I take 1.1. Now my numerator is not problematic. My numerator is 1.1 plus 2, like 3.1. My denominator is going to become what? 0.1 square. Am I right? Now, I'll take another one. Then I'm going to stop, and I want to tell you what's really happening. If I take a closed 1.01, the numerator will be this. The denominator is going to be 0.01 square. So what will happen to the ratio in this scenario? So I have 3.1 divided by something very small. I have 3.01 divided by something even smaller. So what's going to happen actually? So let us compute this number to have really an idea. So if I take 3.01 divided by 0.01 square, how much this is? So that 3.01 over 0.01 square, 0.001. Is this a big number or a large number? Is this a big number or a large number? I want
large.
It's large. It's large. So when I'm taking 3 divided by something really tiny, this is going to give me a large number. Okay, so if you have a number, any number, not 0 a number. So if you have any number, non-zero number, you divide it by a very, very tiny number, this is going to give me a very large number. Okay, so if the numerator doesn't get close to 0, but the denominator is very, very small, this, what we're going to see next time, this is going to really blow up, go to infinity. So that's exactly, so that's going to be next time scenario. Today's scenario will not take that. Today we're going to do the following scenario. My scenario today is both the numerator and denominator become close to 0. So that's the scenario we're going to really focus on today. Suppose I have a scenario where the numerator is small and the denominator is small. Then what happened in this scenario? So if I have a small number divided by a small number. Okay, before we do it mathematically, what type of number do you think we get? Are we going to get a small number or a large number or anything in between? I'm going to think about only in terms of numbers. Suppose I take something very small, I divide by something very small. Do I get a small number? What do you think? A less smaller number, a small number. Okay, not quite. We can get a small number and we can get a large number and we can get anything in between. Let's see why. Okay, let's think of a small number. Let me see 10 to the minus 4. Is this a small number? And I divide it by 10 to the minus 6. Very small, a small number over a small number. What type of number, if we take, what do I get? 10 to the minus 4, 10 to the 6, or let me take 10 to the 10, something really, really small. 10 to the minus 4 over 10 to the minus 10 will give me 10 to which power? Right, I changed a little bit, Gavin. So 10 to the power 6, which is large number. So I took small over small, I got a large number. All right, now, if I flip it around, that's a small number. That's a small number. I divide them by each other. This time I'm gonna get to the minus 6, which is a small. Okay, now, so the problem is problematic. When you have two small numbers, you know, we don't know really what we get. Now, another scenario, I can get like 10 to the minus 10, which is small, but I multiplied it by 2, and I divided by 10 to the minus 10. That's a small and that's small, but the ratio is equal to 2. So the idea is when the numerator and the denominator both become very small, I actually have no idea what's going to happen to the ratio. It could be large, it could be small. It's really going to depend which one is smaller. So if this is way, way smaller than that, then it's going to blow up because in the denominator. If this is way smaller, then we're going to have a small number. Are those equally small? Well, then you're going to have a nice number too. All right. So the idea is if I have the numerator is small and the denominator is small, I have really, we don't know what the answer is. It's not large, not small, it could be anything in between. So these are the scenarios we are going to take on today. All right. And they're not very hard. The idea is we're going to do some really algebraic manipulation to be able to handle those problems. So let me start with the example. So suppose, we took this problem yesterday and we're going to take it today. Suppose I ask you the limit as x become close to 2 of x squared minus 4 over x minus 2. Okay, that's a problem that we took yesterday and we plugged in numbers. And if you remember, we got 4. So now we're going to do it without plugging numbers. Let us analyze the situation here. I always like to analyze my problem, and I wanted to do that. When x becoming close to 2, this is 2, that's becoming close to 0. All right, so I already have an issue. My denominator is small. Now let me look my numerator. X becoming close to 2, let's see. This is 2 squared, which is 4, minus 4, this becoming close to 0. So I have really two small numbers divided by each other. So I don't know what we're going to do. That's problematic. So how are we going to manipulate this? The idea is factoring. So the idea is we're going to factor. And we're going to use that a lot. We're going to factor the denominator and the numerator in such a way that we don't have a small over a small to get rid of this scenario. All right. So how are we going to factor this? So it's really simple. It's actually very simple. All right. How are we going to factor? The denominator cannot be factored anymore. It's x minus 2. What about the numerator? It's x squared minus 4. How can we factor the numerator? Okay, that's a squared minus b squared. It's the x plus 2 times x minus 2. So that's, I want you all totally by heart to know that. So usually if you have a squared minus b squared, we can always, it's a minus b times a plus b. Because if you take and you distribute, you get a squared plus ab minus ab, which we cancel out, minus b squared. And we're going to use this factorization a lot. All right, so what's the benefit of that? Let's see what the benefit of this. By doing this, my problem is I have 0 over 0. those terms, because they are factors, only factors, could be simplified. And by doing this, this will become the limit as x goes to 2. So this expression is nothing more than x plus 2 now. Okay. So the goal of factoring, because this become close to 0 when x close to 2, is basically, it means I should be able to factor the x minus 2. I mean, there are rules in math tells me that if 2 makes this numerator 0, I should be able to factor the x minus 2. So this is equal to that, but now this is not hard anymore. When x become close to 2, this is almost 2 plus 2, the answer is going to be equal to 4. Okay, so now the key thing we're going to do in this section, one of them, to find those limits, we're going to do algebraic manipulation. Okay. Usually factoring will be one of the main algebraic manipulation we will be doing. So I will do another one. I mean, of course, I'm going to do a lot today. So let me take another simple one as well along those lines. So the limit as x become close to -3 of the following. So x plus 3. So I'm making sure my denominator goes to 0. And I'm going to create a scenario where my numerator goes to 0 as well. Okay. So I give you a minute, not more, for you guys to figure out this problem. First, you analyze. Is the denominator going to 0? Okay. -3 plus 3, yes. Is the numerator going to 0? Okay, I always look at it. I don't just jump to factoring. Okay, this x squared should become to 9. And this will become close to -2 times 3, that's a -6. Right? So that's going to give me a 3. -3, so this will become close to 0. So I have something small over something small. I need to manipulate to do it. So I give you a minute and see what you guys can come up with. Somehow we should be able to simplify the x plus 3. That's really what our goal is. Okay, anybody came up with anything? The -4, let's see, it look right. I almost sure. Let's see. So 3 and 1, those should be our candidate. X and x. And there is plus 2x minus 3, so most likely plus and minus. Okay, let's check, double check. X squared plus 3x minus x, give me plus 2x minus 3. So this and this will simplify. So I will have the limit as x become close to -3 of x minus 1. Okay, now when x become close to -3, I will have -3 minus 1, which is -4. So basically, if you take this expression, start taking value close to -3 and plug them here, you will get exactly -4. All right? So now let's keep going. So we're going to do problems along those lines, and every time we will do different. So now let me, suppose I give you the following. Limit as x become close to 3 of, let us say, 2x squared plus 1 over x minus 1. All right? Do we have an issue in this problem? Do we have an issue? So we don't really jump. We always see. When x become close to 3, this is becoming close to 2. So I really don't have issue. My denominator is safe. So this is to remind you that we don't factor immediately, we always analyze. And this will become close to 2 times 9 plus 1, so we are safe. So this here, because the denominator is not going to 0, you actually can just split it. Mainly because this doesn't go to 0. That's really why I can do that. As x become close to 3, as x become close to 3. And this will give me 2 times 9 and that's give me 18. 18 plus 1, that's give me 19, and that's give me 2. Okay. Right, now let us take other scenarios. Please ask questions as we move on. Okay, let's take the following scenario. So suppose I ask you to find the limit. As x become close to 4, so it's stated differently, and those are type of limit we will encounter very soon when we hit derivative. The square root of x minus 2 over x minus 4. Okay, so looks a bit harder, a little bit. And first, do we have a problem? Do we have an issue? What do you think? Do we have an issue? Yes, because when x become close to 4, the denominator becoming close to 0. Absolutely an issue. What about the numerator? Does also become close to 0. When x become close to 4, okay, the square root of x become close to square root of 2. Minus 2, so I will have 2 minus 2, 0. So I really have a serious issue. Numerator, denominator become close to 0. So how we are going to manipulate this problem? Okay. Now factoring is one possibility, but we have to know what to factor and how to factor. So there are two ways you will be doing this problem. I factor the denominator. Okay, I like that. So we're going to do this problem in two ways. First, I will follow your classmates' first approach. Factoring. And okay, first approach. We're going to factor the denominator. So what your classmate is suggesting is the following. She took x minus 4, okay, and she said that this could be written as basically minus 2 squared. Okay, she rewrote it like this. Now it has the form a squared minus b squared, so she factored it into the square root of x minus 2 and the square root of x plus 2. Absolutely correct. So we're going to do it this way first. So let's do that. So the limit of this is going to be equal to the limit as x become close to 4 of, okay, square root of x minus 2. I will not touch this piece. Is the denominator that we're going to factor into the square root of x minus 2 times the square root of x plus 2. Okay. Now the goal of this is really to get rid of this 0 here and 0 here. So these terms do simplify, and then this would leave me with the limit as x become close to 4 of 1 over the square root of x plus 2. So finally, this will be equal to, when x become close to 4, I will have square root of 4, which is a 2. I will have 1 over 2 plus 2, so it's going to become 1 over 2 plus 2, which is 1 over 4. Okay, and this would give me the limit of this expression. Now, if you have do it numerically, it's definitely going to take way, way longer, and this is really more accurate in this scenario. All right, there is another way to do this problem. Either way is acceptable as far as I am concerned, but another way is probably you should be aware of it because we may need it in other situations. So again, my problem is the limit as x become close to 4 of square root of x minus 2 over x minus 4. Okay. The other approach is what we call like rationalization. It means we going somehow to try to get rid of square root of x. I mean, kind of. So the idea is the following. You have the square root of x minus 2, x minus 4. That's called rationalization. Okay. The idea is to multiply the numerator and the denominator by what we call the conjugate of that, which is basically the same term, but instead of a minus, we put a plus. And we'll see in a minute the benefit of that. So instead of a minus, we're going to put a plus. Okay, let's see what the benefit of this is going to be. Okay. By doing that, so I did almost the opposite to what was done before. So by doing this, if I multiply those out, what will I get? Square root of x times square root of x, I will get the x, basically, but that's becoming a minus b, a plus b. So this will give me a square minus 2 square minus 4. And then divided by x minus 4 square root of x plus 2. Now again, the main benefit now, we isolated the x minus 4, so it's a factor in the numerator, it's a factor in the denominator. I'm comfortable simplifying it, and then I'm back to where I was before, the square root of x plus 2, as x becoming close to 4, and this would give me 1 over 4. Okay. So we're just manipulating. We're just manipulating basically to get rid. The goal is not to have the 0 over 0 anymore. That's really what we are trying to do, but we're trying to do it correctly. Okay. Let's do 2 more problems along the same line with a little bit, every time we try to make a little variation. So let's do the following, and I'm going to let you think a little bit about it. So suppose I give you, find the following limit. Okay. Limit as x become close to 2, for example. I don't know why I put 2. There is nothing magic about it. 1 over x minus a half over x minus 2. Okay, it looks horrific. Let's see. Question number 1. Do we have issues? Do we have issues? X become close to 2. Definitely, this one is going to become close to 0. Not only that, when x becomes close to 2, this will become 1 over 2 minus 1 over 2. This one is going to become close to 0. So I really have the worst case scenario. So how are we going to get rid of this mess? What do you think we should do? I'll give you a minute, 2 minutes, so you guys kind of, put your head around it. And what you're gonna do? We have a mess, I mean, kind of. Anybody have any suggestion? What's bothering you a lot? What's bothering you in this expression? That you want to kind of fix it. Make it smaller fraction. Okay, she's right. How can we make that? First, multiply numerator by reciprocal. Oh, that I don't understand. What do you mean by that? I think you're right, but I don't know. I have to make it clear. What do you mean by that? Multiply the numerator by the reciprocal. So if I think I understand, the student want me to do that. No, she said the numerator. No, I don't understand that again. First, multiply numerator. So, oh, okay. So 1 over x minus 1 over 2. I'm still struggling here. Okay, this is equal to what? Can you talk a little bit so I know exactly what you're saying? Because I don't think I'm understanding the writing.
I just wanted to multiply by 1 over x minus 2. the top expression.
So you want me to multiply this by?
1 over x minus 2.
Ah, okay, we can do that. So I have no issue with that. Absolutely correct. Absolutely correct. But still, we still have an issue. What do you think I'm going to do next? Still, I don't know what to do with it. I mean, I'm really still stuck. Find common denominator. Yeah, that's really a good idea. This is a mess. I don't know what to do with it. I'm going to find a common denominator here. Find common denominator. Because we need to simplify this expression. Very good. So now let us find the common denominator. So this will be, I'm going to keep it like this because it's a correct statement. I don't have so. And we need to find the common denominator here. And this is, I will not touch at all. All right. So common denominator. Of course, the common denominator here is 2x. 2x. And then I will have to find a common denominator. I will have to multiply this by 2 and this one by x. So I'm going to have 2 minus x. Okay, so now it's starting to look a little bit better. So it's not a mess anymore like before. So it's 2 minus x over 2x times 1 over x minus 2. Okay, but still we have a mess. We're still not done. How can I simplify it? I really want to get rid somehow. I need to somehow get rid of this x minus 2, which is giving me a problem. Now, are we ready to simplify? What do you think? So I have 2 minus x here, but I have x minus 2 here. So I cannot quite simplify them because they are not the same term. So if I had the same term here and here, simplify. But 2 minus x and x minus 2 are only opposite. So now what I'm going to end up with this 2 minus x, I'm going to write it minus x minus 2. And why I do that? Because I want this to show up. And am I correct? Minus x minus minus plus 2. So finally, I'm going to have this one times 1 over x minus 2. And at this stage, we are ready. This term do cancel each other. And I will be left with the limit as x becoming close to 2 of minus 1 over 2x. And finally, when x becomes close to 2, this will become 2 times 2 will become close to 1 over 4. End of the problem. Okay, so the main idea here was the following. Find a common denominator in here. Because once we find this common denominator, I can at least simplify the expression a little bit. And that's really what happened here. We found a common denominator, which is 2 minus x, and then we multiply by the reciprocal of the denominator, which is how we divide fractions. Once we did that, we realized that we can almost get rid of x minus 2, but not quite, because that's 2 minus x. So we took a minus away. This will give me x minus 2 because minus x plus 2. And this prepared the problem for absolutely to be able to do it. Okay, so a lot of variation of finding those limits algebraically. So the first ones we did, we factored numerator, denominator. The second problem we did was along rationalizing or flipping. You don't have to make. No, why would I have to make the denominator negative? No, because this one, I want to keep it x minus 2. Okay, it's this piece, which is 2 minus x. I would like to simplify it, but I can't because 2 minus x and x minus 2 can't be simplified. So that's why I took up the minus from here, but this has to be the same. No, I'm not changing the top. You're right if I was changing. But in this scenario, I am not changing the top. What I am doing, I'm not changing. What I'm doing is I'm rewriting 2 minus, I'm not changing. That's crucial. I'm rewriting it as this way. rewriting. It's not changing. Let us think, are those two equal to one another? That's my question. Are those two equal? Factor out the minus, you get minus x minus minus plus 2. So those are absolutely the same quantity. So I'm not doing anything. I'm just rewriting. I'm taking this, I am rewriting it that way. Rewriting, not changing. I rewrite it so I can simplify. Is making any sense? Yeah, sure. All right, so now we're gonna, as I said, today it will be problem along those lines. So let me give you the following problem. And another problem that will come up with us later on is the following. Find the limit. And let us say h goes to 0 of the square root, I know, 1 plus h minus 1 over h. Okay, so it looks really horrific, but you should be able to do it. First, we analyze it when h goes to 0. Definitely, so instead of using x, I used h, which should not bother us. The denominator is close to 0. And here I will have 1 plus 0, which is a 1 minus 1. So my numerator is 0. Okay, so we're going to find this limit. And factoring doesn't seem, we don't know what to factor here because I have h. So I have a square root, I have h. So the way we're going to do that, and I want you to do it, you do what we call rationalization. It means you want to do it by multiplying. We want to get rid of the square root somehow. Multiplying numerator, denominator by the conjugate of that. So what do I mean by the conjugate? It means what am I going to multiply by? Okay, what do I mean conjugate? What shall I multiply by? Anybody?
Just change to positive.
Right, I changed to positive. I want to make sure all of you change to positive. And the goal will be, because that's really a trick here, is somehow it will help me to get rid of the h here. So, but now what I do to the top, I do to the bottom, because right now I am not rewriting, I'm actually changing, I'm multiplying by it. So now I have to multiply the denominator. All right, again, let us see what's the benefit of that. And the benefit will be basically getting rid of this h down there. So now that's h times plus 1. Very good. Now let us see here. So this is again have the form a minus b, a plus b, a minus b, a plus b. So when I multiply them, I should have a squared. It means I should have this one squared minus 1 squared, basically. Okay, and this will give me the following. All right. 1 plus h minus 1 divided by h times the square root of 1 plus h plus 1. If you guys working with me, you have to start seeing the benefit of doing this. The benefit is the plus 1 minus 1 really will simplify, and I will have the following limit.
Do we have to keep writing the limit, or can we just like set it equal and then keep?
No, you have to write the limit.
Yeah.
You have to write, because you're actually computing limits at the end. Because you have to compute limit. If you keep writing equal and you had the limit, it's not equal anymore because it is a limit. H simplified plus 1. So
I have a question.
I'm listening. Yes.
How'd you get from the parentheses square root of 1 plus h squared to 1 plus h minus 1?
Let me call this line 1, line 2, line 3, line 4. Which line? From where to where?
From 3 to 4.
3 to 4? Here? Okay. Square root of 1 plus h squared is what? So if you take the square root of something and you square it. So if you take square root of...
okay, they cancel out.
Right. Because that's what the square root is. What's the square root of 2? It's the number. When you square it, you get 2 back. Okay? So when I take this and I square this, I get the 1 plus h. All right? Minus 1 squared. Make sense?
All right, thank you.
So,
It makes sense now. Thank you.
okay. So this is equal to that. Now, when h goes to 0, I will have 1 plus 0, which is a 1. And I will have 1 plus 1, which is equal to a 2. So here I let h become small. I'll have 1 plus something small, which is a 1, plus a 1, which is equal to 2. And I will get a half. Okay, so this is basically a good, almost all the problems that you will be encountering in this section will be along one of the lines we did today. Either you factor numerator denominator. If it involved the square root term, you either factor if you can, like the first problem we did, or you multiply by the conjugate. And if you have those fractions, you go after a common denominator. Okay. Now there is still one type of problems that I don't have time. I will talk about it tomorrow, but it's fairly simple, the other one. It's when the function is given piecewise. Right, any questions before we finish?
Do we have the quiz tomorrow?
Absolutely.
Okay.
Yeah, you will have a quiz tomorrow. So please make sure you do those homework. One of those will be on your quiz for tomorrow. So I will put the problems on my lab. And I realized some of you sent me email that I didn't answer because for some reason unknown to me, all those emails ended up in the junk. I don't know why, but I will get back to them today. Okay? Any questions? All right, meet me in my office hours if you have any problems. Okay? Bye for now.